Friends, welcome to this video. Today we'll learn about the commutative property of rational numbers. Let's see what is happening in class today. Children, Rahul went from Delhi to Kanpur for some work and then from Kanpur to Prayagraj. Distance from Delhi to Kanpur is 495 km and the distance from Kanpur to Prayagraj is 205 km. So how much distance did Rahul traveled to reach Prayagraj from Delhi? Children, you must have got the answer as 700 kilometers. Now when Rahul had to come back, he went to Kanpur from Prayagraj and then reached Delhi from Kanpur. So children, can you find out the distance he traveled? Yes, you are right, 700 kilometers. Children, here we can see that Rahul covered equal distance in both the situations. While adding these numbers here, we see that changing their order did not change the answer.
Sir, two integers are being added here.
That is why, in every case, the sum of the equations is the same.
Because the addition of integers
Is commutative.
Rightly said, Sohan. Now explain to everyone the meaning of commutative property.
Sir, commutative means that even after changing the order of numbers in an operation, the result doesn't change. That is, the change of order doesn't affect the result.
As we have seen here, if we add these two integers in any order, their sum does not change.
If we add or multiply any two integers such as a and b in any order,
There is no change in the answer.
because the addition and multiplication of integers are commutative.
You are right, Sohan. Sohan, in the last class, we learned about the commutative property of natural numbers, whole numbers, and integers. Now let's discuss the commutative property of rational numbers. Rational numbers are numbers that can be written in the form of P by Q, where P and Q are integers and Q is non-zero number, such as 4 by 7, minus 10 by 49, etc. We can also write natural numbers, whole numbers, and integers as P by Q. Here, we can write 1 as the denominator.
So these are also rational numbers.
Let us now discuss the commutative property.
Of addition of rational numbers.
Suppose we have two rational numbers.
Now let's add them in this order.
How do we add such numbers? Like we used to add fractions, with the help of the least common multiple, LCM. Here the least common multiple of the denominator is 12. Adding these, we will get the answer 11 by 12. Now let's change their order and again add them. We will see that the answer will still be 11 by 12. Children, now you add the numbers given on the screen in this order. Keep in mind that the number 5 that is in the first question here can also be written as 5 by 1. Pause the video and solve these questions and write the answers. These are the results. Now change the order of these numbers and add them again.
Sir, even after changing the order, our answers are the same.
Children, you can all see that changing the order of addition of rational numbers did not affect our answer.
Because the addition of rational numbers is commutative.
That is why we can add any two rational numbers like A and B in any order. Children, but is the subtraction of rational numbers also commutative? First, let's take two rational numbers, such as 3 by 4 and minus 5 by 6. Now first subtract minus 5 by 6 from 3 by 4, which we will do in this way. Next, change the order of the numbers and subtract 3 by 4 from minus 5 by 6 and state the answer.
Sir, we have got a different answer in both the cases.
You are right, Mohan. Solve all the questions given here. Please pause the video and solve these questions and write your answers. Now change the order of numbers in each question and solve them again.
In each of the given questions, our answer changes whenever we change the order of numbers.
We can see here that changing the order of numbers in subtraction changes our answer, because subtraction of rational numbers is not commutative. That is why we can say that
For any two rational numbers, a and b, a minus b is not equal to b minus a.
let's go ahead and discuss the next operation, multiplication. Is multiplication of rational numbers also commutative? Let's see. For this, we take two rational numbers. Multiply both these numbers.
The answer is 35 by 12.
Now let's change the order of these numbers.
Sir, our answer is still 35 by 12.
Now all of you solve these questions. On solving these questions, you must have got these answers. Now change the order of these numbers and multiply.
Sir, swapping the numbers did not change our answer.
You are right, Mohan. This is because the multiplication of rational numbers is commutative.
We can say that
A multiplied by B is equal to B multiplied by A for any two rational numbers A and B. Children, now let's check the commutative property of rational numbers in division. Now look at the two rational numbers given here and divide them in this order, keeping in mind that 2 to the power of 2 is 4. Now change the order of these numbers and then divide them. What did you understand from this?
Sir, here the answer in both situations is the same.
Children, considering this one example, can we say that the division of rational numbers is commutative? Let's see some more examples. Children, now look at these rational numbers and divide them in the same order. Write the answers in your notebook. Now change the order of these numbers and divide them again. Now compare the answer with the answers that you have written in your notebook.
Sir, on changing the order of this question, our answers are different. When we divide 0 by 5, the answer is 0. But dividing 5 by 0 gives the answer 5 by 0.
By dividing 5 by 0, we get an undefined answer. Here, with the help of examples, we have learned that when we divide two same numbers, we get the same answer even if we change their order. But generally, if we change the order while dividing numbers, our answer changes. This is because division of rational numbers is not commutative. So friends, in this session, we learned that the sum and multiplication of rational numbers is commutative, but subtraction and division is not commutative. In the next video, we will see some examples related to commutative property of rational numbers. That's all in this session. See you in the next session. Thank you. Friends, welcome to this video. Today we will see some examples based on the commutative property of rational numbers. In the previous video, we learned that the sum and the multiplication of rational numbers are commutative, but the subtraction and division are not commutative. Come, let's see what is happening in this class. Children, look carefully and tell which of these options is correct. All of you solve these questions.
Sir, we can multiply rational numbers in any order. Therefore, the first option is correct.
Absolutely correct. What do you think about the second option?
Sir, the second option is wrong because the subtraction of rational numbers is not commutative. We can see here the answer on the LHS is 1 by 4. And the answer on RHS is minus 1 by 4. But sir, the third option is correct. The answer on LHS is 29 by 20. And the answer on RHS is also 29 by 20. This is because the sum of rational numbers is commutative. And the fourth option is wrong. We can see here the answer on the LHS is 5 by 6 and the answer on RHS is 6 by 5. It is not equal.
They are reciprocal of each other.
Sohan, your answer is correct. But what do you think about the last option?
Sir, if we look at the left side, that is LHS, then we can write square root of 9 is equal to 3 and square root of 25 is equal to 5. In this way, we can write square root of 9 by 25 as 3 by 5. Now we can write LHS as follows, which is equal to 3 by 5 multiplied by 7 by 4. We know that the multiplication of rational numbers is commutative. So we can also write 3 by 5 multiplied by 7 by 4 as 7 by 4 multiplied by 3 by 5. Because changing the order will not change the answer. We can see that in our option, LHS is equal to RHS. That is, the last option is correct.
Children, now fill in the blanks. All of you try solving this question. Sir, the answer to this question is 11 by 9. How did you get that, Mohan?
Sir, in this question, we have to find a number that when multiplied by the square root of 4 by 3 gives an answer equal to the product of 11 by 9 and 2 by 3. The square root of 4 is 2, so we can write it this way. We can also write the given question as, solve it now. We know that the multiplication of rational numbers is commutative. So if we write 11 by 9 on the blank space here, we can see that the left side is equal to the right side. That is, our answer is 11 by 9.
Children, in this video, we saw examples related to commutative property of rational numbers. That's all in this session. Thank you.